Hey guys, welcome to day 49 of Codeforces Everyday until GM. Today we are doing Educational Codeforces round 187, rated for Div 2, so Div 2 contest. Hopefully we'll do well. The goal is 3 questions. We will fight for 3 questions today. Let's get out our whiteboard. Be as prepared as we can before this contest starts. And we're going for 3 questions, or at least 2 questions really fast. I think 3 questions will guarantee that I don't lose rating, but if I do 2 questions fast enough, I should be safe. But okay, like the idea is never to only do 2 questions, right? The idea is always accuracy over speed, right? So the more questions I can do, the better. But yeah, I mean, we've been working hard, right? We've been doing some 1200, 1300 problems. So I think it's doable. It's gonna be hard though. The new gen 1200 questions are actually pretty. They take me a pretty penny. Um, I guess pretty penny is not the right word here. That means money, but like a good amount of time. You know, I can't really guarantee whether I take 30 minutes on it or like an hour on it. So okay, yeah. The contest started. Let's jump straight into it. Come on, Codeforces. Although every time there's a contest, Codeforce is always really slow about it. So, like submissions and stuff, just annoying. Oh, I have my autocomplete on. I need to turn that off. Inline. So just okay. There we go. All right, jump straight into it. In identical boxes, each box weighs. The weight of each box is m. The durability is d. To save space, one wants to build several towers, stacking them on top of each other. Each tower will consist of a positive, greater than 0 integer number of boxes stacked on top of each other. To make sure that no box breaks, the following condition must be met. For each box, the total weight of all boxes above it must not exceed the durability of that box. Help this person calculate the minimum number of towers he can achieve, given that in each of the n boxes must be used. So we have a test case t equals int input. Just take in our input for in range t, and then we have nmd. We got to use map int input split. md. Okay. Build several towers of boxes, stacking them on top of each other. Each tower will consist of a positive greater than 0. Okay, what's going on in identical boxes? Weight of each box is m, durability is d. Build several towers. Each tower will consist of number of boxes stacked on top of each other. To ensure no box breaks, the total weight must not exceed the durability. Okay. The minimum number of towers he can achieve. So let's check this one case. The durability is 20, so you would need 8 boxes, all weight 1. So you would need 20 boxes of 6. This is a pretty easy problem, I will say. It's basically checking his durability. It's like 8 times 10 divided by 20 or something. 8 times 10. You have 8 boxes, each weight 10. Wait, can it be equal to? It must not exceed. I guess it can be equal to, but we only output 3 here. 8 times 10, we have 8 boxes, each durability 10, 20. So like I get 4 here though. We can make 3 towers? How? The total weight of all boxes above it must not exceed the durability of that box. Help him calculate the minimum number of towers he can achieve. This just feels like there's some math answer to it. Right, where it's, okay, let's look at the notes. The first example is possible 3 towers consisting of 3, 2, 3 boxes. How's that work? Having 3 boxes would be... Right. I probably don't understand the durability or something. Well, basically, the bottom box must support the weight of all the boxes on top of it. Right, so it's like boxes. Uh, this is a good thing to note. Um, because the bottom box isn't carrying its own weight, right? It's only carrying the weight of the boxes on top of it. Um, so if the tower has a height of h, then it carries the weight of h minus 1 boxes. So h1 minus 1 times m should be less than or equal to d, which means h minus 1 is less than or equal to d over m. Since it's an integer, double divide h is less than or equal to d double divide m plus 1. So that seems like the solution here. So this is the height of the tower. This is the max possible height of the tower. Now what we need to do is the total height. Okay. Let's put this in real quick. H double divide m plus 1, or d. Minimum number of towers. n is the number of boxes, so it's n is the number of boxes. Well, still haven't turned this off. Minimum number of towers needed is n. Okay, this is our 2 print. We have n boxes. We need n divided by h. Well, it's like n. It's seal. Import math. It's math.seal in divided by h, right? And print to print. Huh? Oh. Okay, this doesn't make sense now. It's 3, 1, 5. Oh, double divide. Since I'm using seal, I don't need that anymore. Okay. Think about test cases real quick. Is there any edge cases that break it? So like case where let's just test and where the number of box where the durability is greater than or where the weight is greater than the durability. Each tower can only have 1 box, so there should be 5. Expected. Oh, why did I type in 3? Should be 5. Okay. Maybe when d is equal to m, or d is divisible. Okay, we already have that case. Like, where d is equal to m. I think it just works. Okay, let's just submit it. Oh. Okay, and we move on to the next problem. Come on, Codeforces. Bro. Okay. Beautiful numbers. And we got accepted. Nice. Define f of x as the sum of digits of x. Okay. beautiful if the sum of the digits of the sum of the digits is equal to the sum of the digits of x. So you're given an integer x, choose any digit and replace it with another. Cannot have leading zeros. Minimum number of moves to make it beautiful. Need this. For each test case, print an integer, the minimum number of moves required to make the number beautiful. Okay, so x equals int input. Well, we should make this a string. Just input, and then for digit in x, sum equals 0. For digit in x, sum plus equals digit. Now, first number is 1. 1's already beautiful. Why? The sum of the digits is 1. You can choose to replace it. So the sum of the digits, the sum of the digits. Okay. Yeah. So this is like the this is like the brute force, right? Like, and then you check if they're equal. And now we need to do the replacing. But I wonder if there's like a better way of doing this that doesn't require. Like, we need a better way of doing this than brute forcing. We get 10 to the 18 and 2 seconds, so we can't brute force it. It has to be like so f of x equals f of x. What does this mean? Sum. Well, the sum of so if like through 0 through 9, it by default it works already, right? Because the sum of the digits is literally itself. So basically, f of x right? 11 would be 2. 10 would be 1. So yeah. A number is only beautiful if it's less than or equal to 9. That's good. So we basically change the minimum number of digits so that it's less than or equal to 9. So this is a sorting problem. We need to like hmm, we need to hmm. Like this is what I'm thinking. We sort like we keep track of the old number and then we sort the number and then we greedily choose like the biggest numbers and replace them with 0. And then so we'll have an x that's filled with holes and the sum of the digits of x eventually will be less than or equal to 9. Something like that, right? So and we're counting the number of moves. So okay, so let's work with a list. Let's not use string here. String just makes us like run into a few issues. We should avoid issues because we should be able to remove things. List, map, int. Does this work? Like I wonder if it just I don't know how I'm still not familiar with this. But okay, it does work as I expected, because I'm the goat and I knew it would work. And then we need sum. Let's call it s equals sum x. And then we need to check. This is our first case. If s is less than or equal to 9, print 0 moves, continue. Now we sort it. Sorted x equals sorted x reverse true. To print equals 0. Sum or like cur sum equals s for digit in sorted x. For digit in sorted x, we want to check if the current sum is less than or equal to 9. If it is, we break. Sum is less than or equal to 9. If it is, we break. And then we print to print. If it isn't, then we change. Yeah. Okay. This should work. Because oh, yeah, we don't even need this step. Because we only care about the moves. We don't care about what the number looks at the end. The digits are going to be the same in either way. The sum is going to be the same either way, no matter what order the numbers are in. So we can just straight up sort it, and then we if the current sum is less than or equal to 9, we break. If it isn't, we change it to 0. So current sum, we subtract. We don't even need to like simulate changing it to 0. We can just reduce current sum by the digit and then increment 2 current by 1. So what that's doing is we got, let's just do 645. We sort it 654, and then we sum this. This is 15. Check current sum. It's not, so we subtract. We have 9. And so once we get rid of it, basically have the sum of everything else. So we don't have to resum in the for loop. That'll give us runtime error, or not runtime, time limit exceeded, right? And then check the next digit. Oh, it is, so we don't have to pop it, and then we can just break and print moves. Yeah. This seems like it works. 654. Why did it give 2? Does it have a... Two moves we can get beautiful number. We can get it in one move. Six five four is 2? 654 is clearly 1. 37. We greedily choose 7 to be 0. And we have 3. So it's one move. Am I misunderstanding the... Ooh, any digit in the number and replace it with another digit. I didn't think of that. There's no shoot. Okay, we have to rework this. You can choose any digit in the number and replace it with another. Six. I mean, 6, 4, 5 is 15. If we replace 6 with 5, it's 14. Oh, let's replace 6 with 5. It's 14. No. 2 moves. 1, 4, 0. I don't get. 1, 4, 0 is 5. Where's 1 and 0 coming from? I don't. That's what I not get. Mm. Ooh, ooh. I think what's causing this to break is actually this rule here. Because what we do is we greedily choose 6 to replace. Well, we can't replace 6 with 0. So instead of subtracting digit, we must subtract like the minimum allowed. So we make it 1. So 1, 4, 5 is 10. Replace the next biggest with 0. So instead of curse sum minus digit, we can't do it like this. We have to keep track of the index. What we can do, I guess, is calculate the possible reductions, right? We can have a reductions array. Uh-oh. Bro. And what that should store is the reductions equals x. Well, we can use x as our reductions array. No need to define a new array. We can do x equals, well, we only have to replace x of 0 equals x equals 1. X0 minus equals 1. Now we have sorted x So technically we have this reductions array. Right, I think this works. Okay, now let's move on to problem C. Test generator. So that question took me what? 20 minutes, I would say. Okay, nice, we got it. That wasn't a hard question. It was just a little bit you had to do a little bit of like thinking for this part. You're developing a test generator. It takes two integers s and m as input. You need to construct an array of non-negative integers, okay, such that the sum of the array is equal to s. for each I, the condition AI and M equals AI, where N is the bitwise AND operation. Okay, so let's just Google that since I'm not the most. I've used this before, but bitwise and Python, just so we can have like a geeks for geeks. So bitwise and is basically saying we only keep the bits where both of them are the same, right? Since these are the same, we keep 1, but since these are different, it's a 0. So this is what's important here. In each number AI, the bits that are set to can only be in the positions where the bits and the number M are also set to 1. Determine whether there exists at least one such array. If it exists, find the minimum possible length in. So, okay, let's just take in our input first as per usual. We will have SM, usually this stands for something else, but okay. Sadist and masochist. And then 2 integers, so copy this. Otherwise print the minimum possible value of n. Or, yeah, we finished our input, right? So what's going on? We have, you need to construct an array of non-negative such that the sum of the array is S. Okay. Each number the bits are set to 1 can only be in the positions where the bits in the number m are also set to 1. Determine whether there exists at least one such array. If it exists, find the minimum possible length in. Okay, so S equals 13, M equals 5. Answer is 3. There's a suitable array. 5, 4, 4. Sum equals S. Oh. Okay. 3, 3, 3, 3, 3 times 12, 13, yes. So the bitwise. So when is the bitwise itself? And 3, bitwise 3 is, this is 1, 2, 3. So we're saying, and, oh yeah, well, if the number is equal to each other itself, then it is. So this is greedy, right? We want, can I ever have not, like, a number bigger, but it's bitwise? Like, 1, 1, 0, it's just, well, I guess it's turning 0011, right? Like, what if I just, what is this number actually? 11002 decimal. It's 12. Zero, because none of the digits match. Okay, so I assume it works by doing it like this, right? Okay, I think what's holding me back right now on this question is my familiarity with bitwise operations. So the sum of every number. Well, okay, so we basically just greedily choose the largest number. Like, how do we find all the numbers that work though? To find all the numbers that work, the maximum is m. Like we have this set of numbers that don't exceed m. The lowest number is gonna be 0, or we can have 0, right? If it doesn't exist, print -1. Something like this. Hmm. Oh, Nico. I think he's doing the contest right now as well. Why am I getting messages though? I should have streamer mode on. Why don't I have streamer mode on? Notification. Uh, Streamer mode enable. It's weird. Okay, so what cases is it impossible? So all these should have the same bits, right? Okay, what is 5 in binary? Dude, I need a binary calculator. Or that's decimal to binary calculator. We have 5. 101. Then we have 3. 1, 1. Wait, that's not right. Oh, 4. 100. So oh, it's literally this one right here. Except this is what, 7? Or bro, I don't know. So okay, so basically this is what M is. M is the bits that are allowed, that we are allowed to use. So for example, let's use a larger M. Let's use M7. How many? Hopefully it's a good. Okay, let's use M11. M equals 11. We get bits 1011. So these are the bits, like, we're allowed to form. These are the bits we're allowed to use as one. Like we can have this, we can have this, we can have this, we can have 11, which is 2. Alright, but we cannot have like 1 here. These are like the positions we can have numbers. We can also have 0, I guess, technically. Which means look at this. What is 13 to decimal? A 1101 and then 5 101. Okay, so I think they should share the same bits, or like share the same zeros. Like there shouldn't be a 1 here, or like here, because then it would be impossible, because we can't make any numbers with 1 here to have that, right? think about this more. So it's 1 only if both bits are 1. It's 0 otherwise. Hmm. My intuition is saying that for impossible, um, S and M should equal to S. I just don't know why. I don't know if it's true because look at this. This works for 5, but I don't know how to prove it either, other than looking at examples. So 1101 6 or 3 would be 11, right? Just double check. Yeah, 11. This is impossible because these bits don't line up. We have 1101 and then was it 6? 110. This is impossible because these bits don't line up. Like S shouldn't have a bit that doesn't line up with M, but M can have bits that don't line up with S, basically. Right? So boom. So what about 110010? 100 is 4. 4 and 12. Okay. Bro, I don't know what I ate yesterday, but my stomach is killing me. But my stomach always ends up killing me in my videos for some reason. Always need to take a dump. Small bladder. I guess it's not the bladder, it's small stomach. I don't know. So, okay, so what do we? I don't know if this is true. This seems true, but I, is it though? It's not. Well, if it's like this, bro, I don't. because it only matters with M. Or like with AI A2, like the stuff in the array, right? So if S, oh, so okay, 1101. Bro, I need to take a dump. Alright, fuck it. Alright, be right back, guys. I'm gonna take a dump. Hey. Okay, I am back. Oh, bro. I can already tell my stomach's gonna be having issues all day. That was not a clean. Oh. Okay, whatever. Back to the question. Where were we? We were thinking. Yes. So, 3. So, okay, it seems like this question is like a two-parter. I kind of want to. What is the big odd number? What is the answer to this one actually? Number 4 is -1, so I don't really care about that one. Number 5. Is the minimum length 11 digits? What? Uh, Wait, this number matters a lot more than I think. Then look at this: three numbers, 5 numbers. It might be some like you can probably do some division trick, right? Since the it's like okay, wait. I might be onto something. It's like there's some check. There's some check with like S and M. Like I can't. I don't know the specifics of it, but there's some check, and then you check if it's possible or not, and then if it is possible, you print negative. If it isn't possible, you print -1. Else, you do some like to print is equal to S divided by M or something like that. Like it might be seal divide, right? Because let me see, 13 divided by 5 is 3. 13. This is impossible. Impossible. What is this? Wait, this one's impossible too, right? No, let's do. Wait, 99 divided by 1. This one. divided by this one is 641.1.01. So we still divide, so 642. This low-key might work. I just don't really, like, I genuinely think it's like to print S math.seal, import math. Hello, hello, hello. Okay, it's how did I forget that split? Okay, but these cases work. Now we just need to check for cases where it's negative, where it's not possible. That's just the hardest part of this whole question. Wait, can we just seal it? The largest value AI can have is M. So we should make each AI basically as close to M as possible. So it'd be like M M M M M M, like as seen here, M M M M M, and then next largest. So yeah, seal should work. Now we just need to check the first part. What is this impossible? It's impossible when this case is impossible. Why? these don't line up, but bitwise not reverses all the digits in it. When is it impossible? It's 8. Oh. So, okay, what is allowed? 1101. We can build it with this, we can build it with this, we can build it with this. Alright, this is 841. So AIs are basically some combination of these, but now we need to cap these. M with M. M is, let's see, 5 in this case. If we have 12, then our allowed blocks are this. This is our smallest block. This is 8, this is 4s. Everything must be divisible by the smallest block. So S needs to be divisible by the smallest block as well, or it's impossible. So we have 13 and 6. We're allowed to use 1101. 6 is 111, which is saying we're allowed to use 100, 11, or 11, 10, and wait. Only multiples of 2 matter. Highlight 2, 4, 8. So 2, 6 is 2 plus 4. Just 6. which means we need to check 13 mod 2. So that's the smallest. Is this it? Like, okay, what if I have a 5? 5 is 4 plus 1. Because that's the largest multiple of 2 I can fit into. Like, okay, if I have 13 and 12, then I would try to fit 8. Like 2 to 3. I fit 8 into this. I get 8 plus 4. So then I need to check if 13 mod 4, and it's not. So we need to check the smallest multiple of 2 allowed. So if S mod smallest multiple of 2, the smallest, like smallest 2 to the n, we're looking for smallest, it's 2 mod smallest in M. Right. So for cases like 13 and 5, the largest we can fit in is 4, so 5 minus 4 is 1. So our smallest is 2 to the O. Huh? I guess it's technically, our smallest is 1, so it works, but then we have 6, our smallest is 2. What is 4 plus 2 plus 1? This is 7. So if we had 13 and 7, we would have 4 plus 2 plus 1. So this would work because our smallest block is 1. Then we get 2, 7, 5. Yeah. Okay. I'm cooking. So basically, what we're looking for is GCD of M and like 2 to the n. The largest, it's like the largest power of 2 that divides M. Okay, 40 would be 2 to the 5 is 32. It's 3. So 8. So in order to get that number, wait, what is like negative 5 binary? What is like one? What? Okay. Wait, I understand that. Okay, so we have m equals 12. One one oh oh. So what? Negative m equals not m plus 1. That's just a thing, I guess. Good to know. Okay, apparently this can get us what we're looking for. So the bitwise not operator as well. So what's the difference between the wait, oh no, that was the one I was looking at. Okay. This shit hurts my head. So I think what we can just do is we can do a equals m and negative m, and then check if s mod a, if s mod a does not equal to 0, negative 1. So m and negative m. So we're getting m and not m and 1. Checking. Yeah. So this will get like the first discrepancy or whatever. Like if we have 12, 12 would be 1100, and negative 12. What is negative 12? Like they just put a negative sign in front, but it's like not right. You hold it with like a you hold this with a bit or something. Like look at this one. 12 and negative 12 is the opposite. Plus 1. So we're kind of just looking for where they're the same. Like we have 0000, 1100, and then 11110100. There's flip plus 1. And then we look for the same. So that's A. And then we check if S mod A does not equal to 0, then print negative 1. Else, print math.ceil. That worked. Bro, if there's edge cases for this, I'm cooked. Like, there's no way I'm getting this. We can look at D. Probably won't have enough time for it. I also need to bookmark this question. Wrong answer. Yeah, okay. I'm not gonna have enough time for this. It's not gonna tell me like what I'm wrong on either. Right, like uh might be this. Python seal without math. What is this? S is saying I can do S plus M minus 1. Yeah, because yeah. Okay, S plus M minus 1. This is like how you seal integers without math, right? So I could technically do this question with it too. I wonder if this changes anything. How much time penalty do I get for mistakes? Because Loki, I think the logic for this works. But I know math.ceil can cause like floating point errors and stuff like that. Yeah, okay, it wasn't that. What cases am I failing on? Like, I wish I knew what I was failing on, so I would know what to look for. My logic seems alright, but we need to find where it fails first and then print the seal. Maybe like S must be represented only using the bits of M. So S and not M, like it must equal to 0, right? If S contains a bit not in M, it should be impossible. Like we established. So maybe something like if S and not M, that don't work. That didn't work. It might be Joe over. What other cases does this fail at? This works for all these bozo cases. S cannot be 0. N cannot be 0. I need to find a case where this fails. I don't really understand. Should print -1. Yeah. What about 6, 4, or 5? I guess 6, 4 should print -1 as well. I think this part's right. It's gotta be this part that's wrong. I have 9 minutes left. It might be chalked. What if we do something stupid? I don't. Where are all the available powers? 64. If M and 1 shift I. Dot append. Put this in here. The thing is, we have to recompute this each time, which I don't like. We brute forcing out here. I don't think this is gonna work, but we can try. Print 0. So negative S. Count should be equal to sum needed divided by e count plus equals, or to print plus equals count. Sum needed minus equals count times P if sum needed is not equal to 0, print -1, else print count, or print to print. It should just be a brute force solution. It doesn't work. It doesn't work. Why doesn't it work? We're overcounting. Still think this is really close. I just don't understand. What am I missing? Did I misread the question anywhere? I have 3 minutes. Wrong answer on test 2. Like, what am I actually failing on? Bro, I've got to be close. I don't even have enough time to look at D. I don't know. I think it's over. 47 seconds. I don't think I'm getting it, guys. If y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. I'll check back with the answer on this question tomorrow. Dude, we were so close. Just fuck. I need to learn. I need to learn this bit operations stuff better. It's like I get it because like I took discrete math and we went over like this a little bit, but it's just so hard to visualize in code for me. I don't know what it is. Like I wasn't bad at like operating, but like it's like a whole different type of math where it's like understanding the flips and everything. I don't know cuz like this feels right. Is it wrong? Like I don't even know where it's wrong cuz it works for the test cases. It doesn't tell me where it's wrong. I can't think of a case where it's wrong. So, I don't know. I'm crashing out. I'll see you guys tomorrow. Bye.